Thank you very much. Thank you very much, everyone. Thanks for being with us. So we're going to talk about how can we all save, I would say, money by replacing aging transformer. The subject will be mainly on larger medium voltage units, but the same principle applies also on low voltage transformer. We're going to have a segment about low voltage transformer towards the end of the presentation. I got quite a lot of material, so I'll try to keep a good pace to save some time at the end for the question period. So again, if you have any question, just note your question, and at the end we'll try to have enough time to go through all the questions. Perfect. So the agenda, sorry, so we'll go briefly over the company overview. We're going to discuss about medium voltage transformer replacement, all the challenges of replacing a larger medium voltage transformer. Also, a solid explanation on standard and energy efficiency. There's lots of misconception in our industry about transformer efficiency and standards, so we'll explain that to all of you. And we'll also present our online energy saving calculator tool to help you out. So, sorry. So the Delta has been around for more than 40 years, 44 years and counting. We are present only in the Canadian market. We don't sell in the US or offshore. So we cover all provinces of the country. Delta made his reputation on quality, on service, on expertise, on support. So it's been the way of doing business since day one, and this is the way we still conduct business. We are over 200 employees at the plant working on two shifts to deliver as many transformer as we can to the Canadian market. We're of course an ISO certified company. All of our products comes from the plant CSA and also UL approved. Some product are only UL approved. Member of Electro Federation Canada and Great Place to Work certified. Just a quick overview at Delta. We don't do liquid fill. We don't do cast coil. We only do dry type transformer, but we do all the types of dry type transformer from the small control transformer all the way up to the medium voltage substation, large transformer up to 44 kV class, 200 kV BIL. So that being said, let's jump in the topic now. My computer is not responding well to the slide of changes, the slides. Okay, here we are. So back in the 1960s and 70s, there was lots of construction going on across the country. And, when you put up a brand new building, it's easy to install a large medium voltage transformer. Usually it's going to be dropped on the basement and then we're going to build the building around it, or it's going to be brought on a certain floor. In the room, we have lots of access because the building is under construction. But then, at the end of life, to replace those transformer, many, many times there's some serious access problems or concern. A transformer life expectancy can be somewhere from 35 to 50 years. We've seen some with longer life, but still, at some point they're going to need to be replaced. And there's many reasons why we need to replace a transformer, whether it's a power transformer or a low voltage unit. Transformer can be at the end of its life. We have more load demand than the capacity of the transformer. The transformer is old with no efficiency, so lots of heat rejection in the room, energy cost consideration. Some older units can be quite loud in regards to noise they emit. At some point, we did a lot of liquid fill, PCB oil liquid fill transformer replacement to be compliant with government regulations. So there's many reasons why to replace a transformer. Um, sorry. There's lots of step to be brought forward when we start thinking about replacing a transformer. First of all, we need to assess the access to the electrical room. We need to figure out what's going to be our overall budget. Of course, if we replace, there's going to be a shutdown. So if we talk about shutdown, we need to talk about temporary power. So the replacement, there's many ways to replace. Are we just going to replace the core and coil, so the inside of the transformer? Are we going to replace everything with a new transformer? Do we have the room for such? And in some markets, like in Montreal and Vancouver, the feed will upgrade eventually to 25 kV. Right now, it's at 12,470. So are we considering a dual wound primary transformer so that, when the utility will change the voltage, we will be up to pace with the new regulation? We need to consider many criteria when we replace a transformer. So we need to know what's the kVA rating we need to replace. Do we keep the same? Do we go larger for demand? What are my primary and secondary voltage and BIL level? The insulation class of the transformer, usually it's 220. Some older transformer can have a lower insulation class. The temperature rise have a big impact on the transformer size. So usually power transformer are 150 rise, but you can have a lower temperature rise, 115 or 80 rise. Do I need something with a lower noise level? There's certain standard that we have to meet, but if your transformer is located where close to occupied area, you may want to consider having a lower noise transformer. The impedance, usually when we replace or retrofit, and if you keep all of the low voltage switch gear, we want to match the existing transformer impedance so that your fault current and downstream breaker are still compatible. Do I go with copper? Do I go with aluminum? What type of enclosure I'm going to use if I replace the enclosure? Is there a sprinkler in the room? Do I need a sprinkler-proof enclosure? What kinds of options? Do I need cooling fans? Do I need temperature controller? So there's lots of questions to go through and ask ourselves when we replace a transformer. Sorry, the PowerPoint is kind of slow to drag. So when we replace transformer, we need to make lots of measures on site. What is important is that we have something that will fit in place, that will connect to the existing equipment if we keep the existing equipment. So, and the main dimension we need to have is the volume of the inside of the enclosure. We need to know exactly where all bus bars, HV and LV comes in the enclosure from the HV equipment and the low voltage equipment. We need the phase orientation. We need the drill pattern. We need the nameplate information. Where we mount the transformer on the housekeeping pad or on the floor, we need to know if there's trenches, cable ducts, is there any conduits. We need lots and lots and lots of pictures, and ideally, if it's available, it's the shop drawing of the existing equipment. That's an example, a project we did a few years ago, an old Westinghouse transformer sitting between a medium voltage and a low voltage gear. So that needs to be entirely replaced. So fortunately for that project, we were able to grab from the building owner a set of the drawing of the existing transformer. Usually, we don't only rely on the drawing because over the years that there might have been modification or changes to the equipment. So it's also a good practice to do a shutdown and to make sure that the information on the shop drawing is still accurate. If there's no availability of the existing shop drawings or information, Delta have developed over the years, so we have forms that, when we do a shutdown, and then depending on your busing arrangement, if the LV is on the left, on the right, same for the HV, and depending on the busing arrangement, are the bus front to back, top to bottom. So we have all kinds of forms that, you and your contractor can, while doing the shutdown, take all the proper measurements so that we know exactly where the new transformer will need to connect on the existing equipment. Of course, when you replace the entire low voltage or the entire switch gear, sorry, it's easier, but because then we work with the shop drawing of the supplier of the new equipment. But when we deal with existing equipment, we need to know exactly where we're going to go and connect the transformer connection points to the existing equipment. So again, all kinds of forms that we can share with you. Usually, the first time you have to do a retrofit, we can provide assistance, either people from Intralec, even people from Delta can go on site and assist you with doing the full measurement of the process. That's probably the most critical portion of the project, is to make sure that we have accurate measures of the existing transformer and existing equipment. Not having the right information will result in not having the right product. One other thing that is also very important is to assess the access to the electrical room. Again, back in the days, or when you build a new building, it's easy. You drop the transformer in place and you build the building around it. But when you have to replace that transformer, you need to make sure that from where we're gonna deliver the transformer, so from the unloading area, it can be a loading dock, it can be in the street. We need to walk that path and make sure that, we measure the smallest opening which the transformer must go through, to make sure that, we design something that will pass through. We got to make sure about all the turning clearances, and always, if you have corridors and you have like a 90-degree turn, we need to make sure that, it's going to turn there. Um, we need to make sure about weight limitation of floor, structural slab, freight elevator, weight limit, freight elevator, door size. We need to know all of that. And also traps such as, ventilation ducts, electrical conduits, sprinkler piping, steam lines. So we've seen all kinds of stuff over the years that, it's important to make sure that, we know exactly where we need to go to bring that transformer inside the electrical room, so that when we deliver the transformer, there's no surprise, there's no hiccups. That's one project we did maybe 10 years ago in downtown Vancouver. The electrical room is in the third basement. It's downtown Vancouver, and the only physical access to get down there was, and still is, a staircase. So one of the options by the contractor and the building owner was to cut the floor in the lobby of the building. It's nice granite and marble slab, and cut the floor in the first basement and cut the floor in the second basement, and use, cranes and hoist in the lobby. But we had an idea of using the elevator shaft and bring the corn coil down in the third basement through the shaft of the elevator. So working with the elevator company, the Coney or ThyssenKrupp of this world, by knowing the capacity of the motor above, and not using the cage for the people, but just using the motor and the wires, what weight can we do? So knowing those size, we designed something that we were able to bring down in the electrical room. Depending on your existing transformer, you might consider different options about winding material. Back in the days, when I started at Delta 20 years ago almost, 75% of the transformer were made with copper, and 25% were made with aluminum. And now in 2026 is the total opposite. About 75-80% is aluminum, and 20-25% is copper. So it's not because your existing transformer is made of copper, we have to go copper. We can go aluminum, but again, copper will be more compact, but will be heavier. Aluminum will be lighter, but the windings will be a bit larger. Do we replace just the core and coil and we reuse the existing enclosure? Do we provide a brand new transformer with a complete new enclosure? And then, depending on your access to the electrical room, do we provide just a typical, I would say, three-legged core, three-phase, three-winding transformer? Or do we go the path of the what we call the three single-phase transformer? I'll explain that a little bit later. So this is a typical three-leg, three-winding transformer. So phase A, B, C, all of your low voltage bus work that will connect to the adjacent or existing low voltage switchgear, complete with fans. So this is a typical unit. One thing that we do at Delta differently is that all of that low voltage busing and HV busing, all of this can be easily disassembled from the transformer. All of that low voltage rack is like one piece of solid bus bar mounted with solid plastic bus, all fully assembled on like a big C channel that bolts on top of the core and coil. So to remove those low voltage busing, mainly, you're gonna have to undo six mechanical joints, so the mechanical joints that attach that to the top of the coin coil, and then you will have your electrical joints from phase A, B, C, and neutral. So usually it's going to be a NEMA 4 connection. So 20 electrical joints, six mechanical joints, and you can lift the entire low voltage bus rack and take it off so that we can have something that will run through that smallest opening, if I could say. In some cases, a three-phase, three-legged core transformer, there's no way, there's no access. So in those cases, we can look at the option of a three single-phase transformer bank. So instead of doing a 1000 kVA three-legged core transformer, we will build three single phase 333 kVA single phase unit, so a two-legged, two-winding transformer. Once reconnected together with busing and flex braid, will recreate a 1000 kVA three-phase system. So those units are much more smaller and compact. And again, we can disassemble all the bus work from the transformer so that only the bare core and coil can go through the elevator, the hallway to be brought in the electrical room. This is what it looks like once it's fully reassembled. Of course, the three single phase transformer option will take more footprint in your electrical room. So in those cases, we need to have the space. It takes about 40%, 50% more footprint than a standard three-legged core transformer. But sometimes moving an equipment in the electrical room and using this option will be much more cost efficient than ripping half of the building down to bring in a standard three-legged core three-phase transformer. When we deal with liquid-filled transformer replacement, usually a liquid-filled transformer is going to be much more compact in footprint compared to a three-phase dry-type transformer. And usually what we need to do in those cases, when you keep your existing equipment, we just turn the core and coil 90 degrees. So instead of having a left to right orientation, looking from front, we have a front to back orientation. And we put flanges or throats on the side of the enclosure to go connect to the existing equipment. Those are a few pictures of a project we did. There were 6 or 7 liquid fill unit in a paper mill up north Quebec. So those liquid fill transformer were removed and some dry type were put in place. So of course, there's a lot of work involved. You have to break down this tank or this basin if you have leakage, and you have to build an housekeeping pad. But at the end, that's the result. So everything is custom built for those solution, custom enclosure, custom core and coil. So that's your front of your transformer, which usually is going to be your right side, and you have flanges on the side like this. And you see here, so the front of the transformer is here, and you see the buswork goes there. And of course, it's a big job to move those transformer in place. But if it's well planned, well done, well executed with the right measurement done up front, uh, 99% of the time, the job can be done, and there's not a piece of steel that needs to be cut or redrilled because it was executed properly and the measures were done the right way, if I could say. Um, at Delta, we use for our power transformer, we use what we call a knockdown enclosure design. So the fully assembled enclosure can be knocked down in pieces fairly easily, if I could say. Two men within 4 hours can bring down the enclosure to the smallest part possible. In most cases, when you deal with replacement, there's no way you can bring a fully assembled enclosure in the electrical room, but the way our enclosure are designed, it's pretty easy. So it starts with, so that's your total result or the fully assembled enclosure, but we start with, a base. So four side, and then we have what we call our corner post. So corner post goes on the base. Then you have your roof assembly. It's made of, depending on the width of the transformer, it can be two, three, four panels with stiffeners, and then the front of the back, and then you drop that on top of your four corner posts. And from there, you put your side panels and you put in your removable panels or hinge doors front and back, and you're back in business. Your enclosure is fully assembled. So depending on the access, you may have to disassemble the enclosure in part or totally to bring it in the room. Usually we ship the transformer fully assembled on a skid like this. At Delta, this is unique in the industry. All of our power transformer are shipped on a wood skid. There's good reason for such. First reason, between our core and coil and our enclosure, there's no mechanical link. The feet of the core and coil are not attached to the enclosure. So this is to prevent, I would say, vibration transmission from the core and coil to the enclosure. In the transformer, as you know, is noisy, it vibrates. So all of that vibration, if it's not well controlled, if it's transmitted to the enclosure, it just creates an amplifier, makes the transformer more noisy. The second reason is to maneuver the transformer and to unload them. If they're separate component, it's easier. So you can lift everything. So the core and coil, the enclosure, and the skid there's an access hatch on top of the enclosure. So you can unload everything from the truck with the lifting provision on top of the core and coil. And then when the transformer is dropped down either on your loading dock or in the street, then you can just lift the enclosure from the skid, and then you can just lift the core and coil from the skid. If you have any disassembling work to do on the core and coil or the enclosure, then you can do it and bring that in the room. We can also provide a service of shipping the transformer disassembled. So we'll ship the core and coil on one crate, all the buswork disassembled on pallets, and the enclosure can be shipped either fully assembled or disassembled, laid flat on a skid. It's more work for the contractor to reinstall, but again, it's something that can ease the process for entering the room and reassembly. In some cases where the transformer are very complicated, especially with three single phase option, we can have, I would say, specific reassembly instruction made by our engineering team. So mainly it's like an IKEA transformer. You receive boxes with parts. Parts are labeled, and then you open your instruction, and part A goes here, part B goes there. So you can put back your transformer with, I would say, customized reassembly instruction. Um, Sometimes there's no way to bring that transformer in your room. There's no passageway, freight elevator. There's no way. It's impossible. So in those cases, you need to be, I would say, creative with the building owner. So that's been done a few times. That's a project that was done last year again in Vancouver. There was no access, so mainly they had to To block the street, we delivered the transformer disassembled. They brought the transformer. You see here the coin coil sitting on that massive platform. So the crane lifted the platform on the side of the building where there was a hole made in the sidewall of the building, and then the coin coil is brought in the building using that hole in the sidewall of the building. It's more money, but again, if there's no option of doing the three single phase coin coil, doing anything, that's the only option. So it's sometimes we have that's got to be done. We've seen that we have to go from the roof of the building. So we've seen all kinds of situation where we had to do this. The challenge for the contractor in the replacement of a medium voltage transformer is first of all, it's the accuracy of the on-site measurement. The transformer will fit perfectly in place if the measurements were done properly. The handling and the rigging operation, again, bringing the transformer and its component in the electrical room is a challenge. That's got to be done properly. The dismantling of the existing transformer, if to bring a transformer in the room is a challenge, sometimes to take away or take out an old transformer is also a challenge. It's got to be sometimes dismantled and cut in the electrical room. The proper installation of the new transformer and the reassembly of all the bus bars and everything. And they got to figure out, what's going to be the cycle time of this entire process. Because again, I'm going to have to shut down the building. There's going to be need to have temporary power. So that needs to be assessed and evaluated. Many years ago, about maybe 15, 16 years ago in Montreal, we did a replacement of liquid filled transformer in one of the highest skyscraper. There were like 10 transformers. And the contractor got so good at the end that, they were shutting down on Friday at 9 p.m. And by, in the night of Saturday to Sunday, the liquid filled transformer was emptied, disassembled. The new transformer was in place. The new gear was in place, installed, commissioned, and energized before Monday morning, 6 a.m. when the office people were coming in. So again, when you have the right crew, the right contractor, the right rig, you need to have the right people to do those type of jobs. But again, if you have the right people, if it's well planned, well executed, it looks complicated, but it's not that complicated, if I could say. I'm just gonna have a sip of water because I'm talking a lot. So standards and energy efficiency. There's lots of, again, misconceptions in our industry about CSA and NRCan, who does what. So first of all, let's talk about NRCan. So NRCan is Natural Resources Canada. That's the federal government. And what's the job of NRCan is to regulate the transformer sales between provinces and to regulate the imports of transformer in the country. And to make sure that, all transformers will meet a certain efficiency standard. Again, when I say that, sales between provinces, the law of NRCan, if you build a transformer in the province and you ship a transformer within that same province, the NRCan standard does not apply. Then it's your local provincial regulation that will apply. Example, Delta, the plant is in Granby, Quebec. I ship a transformer to Montreal within the same province. NRCan is not applicable. It's the provincial regulation that is applicable. Until 2021, it was a big mess because some province like Quebec didn't have any regulation on transformer until 2020. Ontario, back in the days, jumped the gun on the latest one, so we're in pace a year before it was effective by NRCan. But now everything has been harmonized pretty much coast to coast. So when there's a change from NRCan, all the provinces will follow pretty much at the same time. So it makes business much more easier for transformer manufacturers. So mainly, again, NRCan is the law. That's the government. They make a law. And then what do they use for standards for efficiency and everything. So in Canada, we use the standard from CSA called CSA 02.2, which is the standard for minimal efficiency and test procedure for dry type transformer. In the US, DOE, Department of Energy, is the regulation authority, and NRCan, CSA, and DOE are now aligned. So anytime that there's a change in the US, Canada will also align. So it makes the business, I would say, within North America easier. The last change from DOE was in 2016. In Canada, it was in May of 2019. There's going to be another change in efficiency coming in probably 2028 or 2029. It's going to be, again, a major increase in efficiency, increase in transformer costs, increase in transformer dimensions. So we don't know yet exactly where it's going to go, because at first the intention of increasing the minimal efficiency was so high that it would have prevent all manufacturers to use the current material, the current core steel and everything. We would have to jump to amorphous steel. There's not enough capacity in the world to do so. So now there's lots of pushback in the industry on the American government to bring those efficiency level to a point where we can still use material that there's enough volume in North America so that every manufacturer can have access to those material. So it's gonna come. It's probably in 2-3 years from now that we're gonna have to deal with this next efficiency change. So NRCan is government, so they have a nice website. And when you dig a little bit on that website, you can find the pages about dry type transformer. And on that website, you have the data of all manufacturers. So when we build a transformer that complies to NRCan, we have to provide them with the data, and then they will update their website with that data. So if you go there and you look for any manufacturer, Delta, Hammond, Marcus, whoever, Rex, the data will be there. It's the government, so they're not very efficient. So sometimes when we send them the information, it can take up to 18, 24 months for them to update the website. So if you don't find the information, it's not because it's not there. It's because it's our governments which are not very efficient sometimes, like the transformers. So NRCan law, and then we have CSA 02.2, which is the test method for the efficiency of transformer, and the -18, that's the latest revision. So it was amended in 2018, and it was put in application by NRCan in 2019. So when you say NRCan 2019, it's just that in 2019, NRCan passes a law to comply with higher efficiency, but it's CSA 02.18, which contains those efficiency and how we test them to be compliant to those efficiency dictated by NRCan. Of course, it's not all transformers that need to be compliant to CSA 02.2. There's lots of variation in the offering and what needs to be compliant. So mainly I would say the reason of CSA 02.2, it's to base your efficiency on a loading over a day. It's based on the core losses, so the no load losses of a transformer. It's also based on your total loss, and the most important thing about that standard is the efficiency that we need to be compliant with. For low voltage transformer, we need to meet that at 35% load, and for power transformer, we need to meet that at 50% load. So it's quite low in regards to loading. So in that efficiency curve from zero, sorry, for the load curve, so from zero to full load, so we need to meet that efficiency dictated by CSA at one point. So all the manufacturer will measure on one point, but we don't have the same curve. So it's important to understand how we calculate efficiency and what's the losses of your transformer when you want to compare apples to apples. So that being said, generally most transformer will be included in the minimal efficiency standard beside the following. So single phase and three phase, anything below 15 kVA, it's excluded. Single phase, everything above 833 kVA is excluded. Three phase above 7,500 kVA is excluded. In regards with ampacity, power and distribution, and anything above 4,000 amps will be excluded. What we call drive isolation, single output, anything above 1,500 amps is excluded. Any sealed transformers, so epoxy potted, mini power center, fully enclosed like NEMA 4, 4X, NEMA 5, NEMA 12, this is all excluded from the standard. Auto transformers excluded from the standard. And all the what we call specialty transformer, rectifier duty, multi-pulse units, testing transformer, welding transformer, something that doesn't have a 60 hertz frequency. If you build something 50 hertz or 50/60 hertz, excluded. Anything that is dedicated to be exported outside of Canada, it doesn't have to meet NRCant, and usually the customer who buys that transformer has a 6 months period to export it outside of the country. In that minimum efficiency standard, sorry, here it says 12, but it's 18. So in that standard for transformer, we have tables to follow. So depending on your kVA and voltage class, we have different efficiency to meet. Again, low voltage, so anything below 1.2 kV at 35% load. Anything with a BIL of 20 and above, it's at 50% load. So the more you go up in kVA, the more you go up in voltage class, the more you be efficient. And you have tables for single phase and three phase. So this is how it works. So everybody needs to be measured on that single point. For instance, 1,000 kVA, I would say 95 kV BIL, 15 kV class has got to be 98.99% efficient at 50% load. How can I calculate or figure out the cost of my energy? There's different ways to calculate it. So let's say you have no information, you have no losses, you have no efficiency, no nothing. At least you can go with the following. So if you have an existing transformer, 2,500 kVA, 15 kV class, back in the days, they were efficient at more or less 98%. So let's say we use that 50% load. So our load will be 1,250,000 VA, which is watts times 2%, which is your losses. So that equals to 25 kilowatt, 25,000 losses at one power factor. I use the kilowatt cost of Quebec. I know we're lucky. So if you pay only 8 cents your kilowatt, 25 kilowatt times 8, so you have $2 per hour in losses per day, per year. So your cost of energy is about $17,500 per year. Cost of energy, losses burnt in the transformer that you are lost. Don't use them. You pay for that. If you go to I would say, latest efficiency transformer, same criteria. In that CSA table, we see that the efficiency at 50% load is 99.41. So same maths, at 50% load times my efficiency, that's my losses at 1 PF. Those losses times, 8 cents a kilowatt, I'm at barely 60 cents an hour per day, per year. For a year, so I'm about 5,168 in cost of energy. So you save about 12 grand per year on losses burnt in that single transformer. And if you replace the transformer and you expect a 35 years lifetime, you're gonna save over 400K of losses in that transformer. That's huge. Um, in transformers, the efficiency is not linear. So the more you load a transformer, the less it's going to be efficient. So you have two types of losses: the no load losses, the loss in the core that you're stuck with all the time, despite if you have zero load, and then you have the load losses, the losses in your winding. But those losses, they increase to the square of the load. So at 50% load, you generate 25% of your load losses. So the more you load, the less it's going to be efficient. To give you an idea, again, if you want to do some rough calculation, this is a typical example, a Delta 2500 kVA that we have built a few years ago. On our drawings at Delta, we're generous. In that box here, you have your losses. No load losses, full load losses, total losses. From there, you can run the same kind of maths. So at 50% load, no load losses, your load losses, let's say you have a load level of 50%, so zero point 0.5 times zero point 0.5 equal 0.25, 25% of your loss. So you multiply your load losses by your load factor plus your no load losses, so that gives you 8 kilowatt of losses. Same maths with the same amount. So I'm at $5,600 a year of cost of energy, and on the lifetime, I'm at 197K. Again, if you compare to an old inefficient transformer, you're going to save a lot of money. Same maths at 80% load, you end up at $234,000. So you have almost $37,000 difference over the lifetime of a transformer comparing 50 to 80% load. So again, the more you load, the less you are efficient. But the moral of the story here is if you have an old transformer, it's going to cost you a lot of money. So replacing that transformer will save you a lot of energy, cost of energy. We do have a nice online energy saving calculator. This is made for low voltage transformer, 15 to 300 kVA, copper, aluminum. Mainly we use I would say Delta information. So it's Delta archive info from transformer that we have built since 40 years ago. It's pretty easy to use. We did a webinar a few years ago, so on that page you have a tutorial how to use it. But mainly you put in your average load per day, the cost of your kilowatt. So let's say it's 17 and a half cents. You use your transformer 24 hours a day, 365 days a year. You have a 150 kVA made of aluminum. You push calculate, and boom, that transformer that was built before 2012, so you have the losses. A transformer built between 2012 and 2018, which is the previous NRCan efficiency and the current one. So based on those criteria, you're going to have your cost of consumption, or your energy cost per year, depending on the version of transformer. And then you will see what's your saving per year and over 30 years. So if you take a 150 kVA aluminum transformer that was built 20 years ago, you're going to save $3,000 a year on energy, and over 30 years, you're going to save almost $92,000. So that's a lot of money. And you can push export either PDF or Excel, and that calculation, it's available for you from our website in either a PDF form or an Excel spreadsheet. So if you want to do multiple calculation, you can build an entire library of that. So if you have a building, you have 50 transformers, you can collect the data and figure out, in that building, if I replace my existing transformer, this is how much I'm gonna save in energy. Let's go back to the PowerPoint. So that's again a print of your calculation. So to resume, the benefits of replacing aging transformer. First of all, it's the cost of energy. So you're gonna save a lot of money. Your building owner will save a lot of money. not just from the transformer, I would say cost of losses, but also the fact that the transformer is more efficient. It rejects less heat in your room. So your electrical room will be easier to cool and to climatize. You're going to have an increased reliability because instead of relying on an old transformer at the end of life that can fail at any moment, you have a brand new transformer that's fresh. Your cost of maintenance will be lowered. An older transformer will need more maintenance, will need more periodic check to make sure it won't fail. Uh, you do a better usage of your energy because you do more with less for the same money. So that money that you used to spend on losses, now you can use it to spend it on other energy. The transformer consumes less. So you do a better usage of your energy. Your cost of insurance will lower because most of the time when you have old aging transformer that shows signs of imminent failure, your insurance cost can go up. And you reduce the carbon footprint, which is one of the most important thing we need to think about nowadays. To finish, again, just a quick remember about the Delta pillars. You know, Delta has built its reputation on quality, service, and engagement. So every transformer that we build them better. We make business to do business with us as easy as possible, best service in the world, and engagement. So we work with you. So we create partnership with our rep, with our distributor, with consultant, with contractors. So it's Delta is not in just for one order. It's we work with you and we seek long-term relationship. Thank you. That was a lot in in 45 minutes. So we have 9 minutes open for the question period.
Great. Well, thank you, Mario. Fantastic presentation. Very interesting. I think it's somewhat exciting to see that there's another large area of potential savings for energy savings just beyond lighting and motor control. So very exciting. We do have a couple of minutes here. I'm going to get in. We had a few questions that came out.
Yeah.
First one is relating to the energy savings. Mario, are you aware of any federal or local Ontario rebate programs that would help offset some of the cost associated with the retrofit initiative?
Right now there's none. There's none in Quebec. There's none in Ontario. But we are meeting with government authorities to convince them to put some sort of program in place. Because again, with the electrification of everything, you know, at some point, you know, the grid will be saturated. So we need to do more with less. So could you imagine the amount of energy that is lost in all the transformers across Ontario? That's probably equivalent to one other power plant from OPG. So we're pushing on the authority on the utilities in all provinces so that they put in place a rebate program and incentive. But again, it's government, it's long, but you know, we are doing our fair share to try to make this happen.
You mentioned at the very beginning of your presentation
I
that
don't I don't hear you, John. Sorry.
can you hear me now?
Slightly.
Your volume might need to be adjusted. Your computer, maybe you pressed a button.
I'll just have to talk a little louder
Yeah.
here. We had a
Oh,
question
you're
come
good.
in. Good. Okay. The question just came in from Dwayne Horner. If you used an oversized transformer, would the energy cost savings be even greater?
Yes and no. It depends of the how much you oversize your transformer and what load level you put on it. A larger transformer will need larger core, so larger no load losses. So as soon as you energize, you're gonna burn more energy. But again, as soon as you apply load, if you load that transformer less, your load losses will be less. So overall, you may be more efficient by using an oversized transformer or a what we call a lower rise transformer. If you go with a 115 or an 80C rise transformer, same phenomenon. Bigger core, transformer is larger, so bigger core, bigger no load losses, but load losses in the winding will be less. So oversized or low temperature rise transformer will save you money and energy if you load them I would say over 50%. If you don't plan to load those transformer above 50%, you're better with a standard, I would say standard size 150 rise transformer.
In regards to that, this question looks like it's more asking about fault current and downstream coordination based on impedance levels.
Yeah,
Is
yeah,
it possible for a retrofit transformer to have significant energy savings while maintaining the same impedance values of the original transformer?
yeah, yeah, because today, since NRCan and CSA C802.1 and point 2 are in place, we have to meet those efficiency level despite of all other criteria. So if the transformer impedance is 5, 7, 9%, we have to meet the same efficiency.
Okay.
So again, when we replace a transformer and we keep the existing low voltage gear, we match the existing impedance so that we don't have to replace all the breaker, but the transformer will meet the efficiency of CSA and then NRCan. So
Okay. Excellent.
yeah.
Okay, that's the end of the questions. Thank you very much, Mario. I just want to reach out to all the consulting engineers out there as well. If there's Delta and Intralec are commonly putting together lunch and learns for consultant firms. If anyone has interest in an in-person lunch and learn or even an online similar to what we're doing here today, please reach out to Ronak Mystery, who's part of this presentation as well, and some contact information will be available at the end of the presentation here for you. We'd be happy to put something together. We do that on a regular basis. So again, thank you, Mario, and Daniela, I'm going to hand it back to you.
All right, thank you very much, Mario, and thank you, John, for moderating the question period. Thank you to everybody for making the time to attend to this session today. After this webinar is over, we're going to send you an email with a quick short survey to get your feedback on how we could do better for the next one. And it'll also include Ronak and Stefan's and John's contact information, so that will be available to you. And we'll be doing the draw for the 2 lucky winners of the gift certificates provided by Delta. So stay tuned. You'll get an email in your inbox within the next hour or so, okay? And it will also include the recording for today's session for those who didn't get to catch it all. Okay, thank you again, and wish you a safe and happy day.